Hello and welcome to Andy and Ian Talk Networking. I am Andy.
And I'm Ian.
Hey Ian, how are you today?
I'm doing great. Trying out my new glasses, as you can see. I know you always wear glasses, Andy, but I often don't when I'm doing these videos. But today I was told that I should wear them all the
It's
time,
it's
so
the
I'm
age
wearing them.
thing that does it. It's absolutely the age. And speaking of age, time. Let's talk about time. Good segue in
Time.
there.
That's a fantastic segue.
So let's talk about timestamps and what are they, why they matter, and kind of let's look at some use cases around where we can use timestamping in kind of observability. So let's start off with a very simple question: why do we need timestamps in packets?
Well, from my perspective, I believe it's all about accuracy and being able to understand what happened, and more importantly, in the case of a timestamp, when
Hmm.
it happened. You see it on the TV police dramas when they scroll back through the security camera footage and say, oh, something happened at this time or that time. Now, we're talking about a lot more accuracy than a TV crime drama, but the same principle is true. If you know when something happened, you're then able to say, well, hey, this happened at this time. What was going on? What other things were happening
Right.
in the infrastructure, etc. So it's really important to have a clear understanding of when things happen.
Yeah, and interestingly, because obviously you've got the when aspect, but also you can use that timestamp, and depending on the accuracy you're looking at, to identify where it happened. Because obviously something
Yeah.
happens at a specific time, but if you're attaching that timestamp, and that really comes kind of to the second part of the discussion, which is why we need timestamps, but also where we put those timestamps into our data and into our networking. So timestamp tagging effectively is really what we're talking about here. And where can you do that in your network, and where should you do that in the network?
Well, that's a very important question. And I bet you there's people watching and listening to this who are going to be like wildly disagreeing with my comments. For me, it's about doing it as close to the edge in terms of where the data is actually going
Yep.
on the network. We've spoken about taps in previous episodes as an example. So for me, it's about getting the data from a tap into a packet broker and time stamping it immediately on receive on the packet broker.
Yeah.
Now, once again, of course, I'm going to say cPacket is great, but really, a packet broker that offers a time stamping capability right at the edge is really the key. Is really the key point.
Yeah, and it's important to understand, obviously, the timestamp. It's when you timestamp during the duration of that packet matters as well. So, a
Yep.
lot of people might wait until the whole packet's arrived. Okay, that's one way of doing it. The problem you have with that, of course, is the packet is a different length depending on when in the negotiation and when in the transaction is happening. So, for me, you really need to timestamp right at the beginning, that first symbol as it comes
Mm.
into your analysis infrastructure. You need to stamp it right there. And again, the next thing then becomes is what resolution and what accuracy do you use, and what protocols do you use to actually keep all your timestamps synchronized through the network? Because you've got NTP, which is one protocol, but then you've got PTP as well, which is really designed for much more high accuracy.
Absolutely, and probably almost that's a whole discussion in itself, Andy,
Yes. Yeah.
which one is the kind of the better choice. But just coming back to what you were saying before, ideally, absolutely right. It's the first bit or the first word of the packet, and really being able to do it in parallel
Hmm.
across all the ports, because obviously networks are very busy places. There's a lot going on, and that performance demand is going up every single day,
Yep.
week, month, year. The point is, if I receive, I don't know how many fingers I've got, 10 fingers, yeah, if I've got 10 ports of data coming in pretty similar times,
Yes.
right? If I'm time stamping all of those individually, I'm really going to see a ripple as the packet goes through the network, and I should see it all of the different hops as an example. So
Yes.
rather
Yeah.
than, as you said, waiting until either you've received the whole packet or the header, or you're going to send it to a central CPU or something like that, you're going to get a kind of a kind of a
Jitter.
weird effect.
Yeah, you
You're
get
going to
some
get a
jitter on
weird
the packet
effect.
as it's going through,
Yeah,
through
yeah,
this
yeah.
ecosystem.
Exactly. So the point is that if you actually do it just on receive, that's going to be really, really good on all of the
Yeah,
individual ports, or as our NG box does. But the point is that that's going to give you the most precise understanding of
yeah,
what's going on. In terms of the protocol, that's really interesting because you have lots of people, even in a lot of our customers, whose specific job is to handle time. That
yes,
is their job. And they've got some really, really precise ideas, cable lengths, all of the stuff that they really worry about. And obviously, as you said, PTP, is probably more accurate. But more important than that, it's actually having a kind of a PPS input, so that
yes,
you're actually getting that the clock, kind
yeah.
of received into the product, and then you can use that as
and it,
part of your
and that's actually an
synchronization.
interesting thing because in many years ago I played around with GPS quite a lot, and we
Right.
were really excited about having like a microsecond of accurate pulse coming out from your GPS receiver, and that's good enough to tell you where you are within like 20 meters anywhere on the planet. But when you're dealing with 100 or 400 gigabit network, a microsecond's an eternity. So you
Yes.
really need to really drill down and get timing accuracy into the nanoseconds where possible, and you can clearly see in the future that's gonna go out to the picoseconds, and
Yeah.
on a kind of even more tolerance, and that introduces a whole load of problems in the network as well.
Well, yeah. I mean, the point is, you have to have people, as I mentioned. A lot of our customers have these people who are time specialists,
Hmm.
and they are able to help you design the infrastructure. They're working on standards. That, as you said, they're working on the next standard, etc. Bottom line is, if you're starting with time stamping, you want to be able to understand what's going on.
Yeah,
Use that as close, once again, relatively speaking, depending on your infrastructure, as close to the network as you can. Timestamp all of those packets
yeah,
in series, not in sequence, so to speak, and then use those timestamps as you go through. So whether it be looking at the analytics, right? Looking at the latencies, hop by hop stuff that we've spoken about before, etc. Or you're wanting to just get to a PCAP. Maybe that's
yes,
your goal, is a PCAP. Make sure you're using the right time. And then obviously things like replay,
yeah,
when you're playing this data back so that you don't have gaps or packets coming in the wrong
out of order,
order,
yes,
is
yeah, yeah,
really, 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 really critical, because you're going to get a very false understanding of like, hey, why is that packet out of order? Why is this out of order? Actually, it was just your time
yeah,
wasn't
yeah. And
wasn't
this is
quite
key
set.
to time stamping. For me, really is important to feed into those analytics tools, because if you're giving the tools the wrong information, you're telling them something happened when it didn't, and didn't happen when it did. You're really kind of just your underlying fault analysis tools are just going to give you the wrong data out. So it doesn't matter. You can invest millions of dollars into AI and analytics tools to understand what's going on, but if you don't give it a timestamp in the right location, you might just as well not bother.
Once again, absolutely agree with you on that, Andy. Absolutely agree. I think also that, coming back to my silly analogy at the start of the crime dramas
Yeah,
that we,
the
or certainly
timeline.
I love to watch, yeah, all of that, the timeline is critical, because as soon as that's questioned,
Yeah,
right?
it all falls
That's
apart.
when
Yeah,
that's when the whole thing falls apart.
yeah,
And you can then be, well, this person didn't do it. They should be let go. No, 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 it's definitely that application. No, 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 it
yeah,
can't be the application, because I've been your timeline's all off. And you get into this very weird metaphor, fair enough, but also a kind of a situation which you need to really be able to deal with, and having accurate
yeah,
timestamp those packets, whatever method. Really, bottom line is, if you're trying to start out with time, this is really going to help you in your network investigation and analytics journey that hopefully you are on.
yeah. No, I agree, and I think I think we can kind of wrap up there. But in summary, for me, it's all about when you do that timestamp,
Yep.
you've got to do it on every single port, on every single packet. You've got to
Yep.
feed, make sure you're well within the tolerances of your application. So it's all well and
Yep.
good saying, well, NTP or PTP, whatever. Ultimately, you need to be using the right timestamp for your application. Otherwise,
Yes.
you're just wasting your time, really. You're wasting your time. How about that?
A big claim, Andy, but probably accurate. That
Yeah.
exactly is right. Exactly.
Okay, well, great. Thanks. Good discussion, Ian. I just want to invite everybody again to please like and subscribe if you enjoy our content. And thanks for watching, and we'll be back soon next week. Thank you.
Bye for now.